Hello, everybody. My name is David Golub, and I'm here with Julian So, and we specialize in AI and advanced analytics. And we're going to hopefully take you down a path that shows you some concepts and ideas that you can take back to the office and get with your teams and think about the possibilities and ramifications for your organization. So, Esri and Microsoft have a long history of partnering. Years ago, Microsoft put a spatial data type into their database engine, SQL Server, and a lot of that was with collaboration with Esri. And more recently, Power BI has an Esri visualization control that you can drop onto the surface and come up with some really compelling visualizations. But what's exciting, and we're going to talk about today, is the Esri-Microsoft partnership around AI. So let's first level set on what AI is. Really, AI is about machines understanding the world. And we look at AI in the area of perception and cognition. So perception, given an image, can the AI model identify objects in that image? Given speech, if I have some free-form text, can I provide you the sentiment and maybe some of the key phrases? And on the cognition side, can I understand different languages and translate those languages? And the knowledge aspect of cognition is especially valuable. That's what makes this a chatbot interface feel like you're communicating with something that really understands the context of what that might be. Maybe it's buying wine, maybe it's navigating a courthouse. I wish I had one of these yesterday and maybe some augmented reality glasses, maybe a breakfast personal assistant, because when I ordered my omelet, the cook said, "Would you like some of these peppers?" And they were in a little bowl, and they looked awesome. And I said, "Sure," you know. My cognition said, clearly this cook isn't going to hurt me. And in looking at the peppers, they looked delicious. And I sat down, and I cut one in half, and I put it in my mouth. And right away, I knew this was going to be hell. So I grabbed a napkin and spit it out. It was really embarrassing. I went up to the cook, and he said, "Oh, that's a serrano pepper." Well, if I had a little bit of object detection and maybe context around breakfast, maybe it could have saved me some serious heartburn. So that's the broad picture of AI. Let's talk about now the way Microsoft likes to look at AI. And it's really on a continuum. And we're going to look at Esri-based solutions on both sides of this continuum. On the first side, the left side, we have custom AI. And for those that are CIOs of larger organizations, you might have teams of geodata scientists, Python developers, R developers, statisticians. This is where they would hang out. And in this custom AI space, what's really intriguing is when you start thinking about deploying these heavy lift algorithms, you need a lot of GPU power. And the cool thing about the cloud is we make it easy as cloud vendors to just click up and scale up the GPUs that you want and scale them down. And it's relatively low cost. So really, that's been a key revolution in the space of AI today. And then you go to the other end of the continuum. I don't have the Python developers. I don't have the data scientists. Give me something where you have already trained the models to recognize what a serrano pepper is. I don't want to train it. You train it for me. And that's what pre-built AI is all about. When you access these pre-built AI cognitive services, which we'll touch on in a bit more, that's really you wanting a solution up quickly, and you don't have to have those deep data science skilled folks on your team. So let's talk about Esri and ROI. I'm sure all of you get tremendous return on investment from your Esri platform. But the additional ROI you can get when you start thinking about AI use cases is really profound. When you really think about some of the core activities that take place on that Esri platform, you have these ArcGIS engineers and users managing these layers And these layers, they represent any number of things: ownership parcels, zoning, tax law, vehicle accident, etc. There's a lot of information in these layers. And those layers have intrinsic patterns, maybe predictive patterns. So that's really a key area that you can look at when it comes to AI and additional value with your GIS information. So we're just going to talk about just a few solutions. So you could have a layer representing energy sites, so drill sites, gas fracking sites, and maybe you want to track drilling and construction progression. So you could look at imagery and you could train a model maybe that can see construction equipment. More prevalence of construction equipment, it means that project, that drilling project is at a certain state. Less, why hasn't it started already? So this could be really valuable for a state to understand. Accident remediation. You have layers capturing accidents over time. So you have location, you have road information, mash this up with weather data, mash it up with time of day. Maybe you can begin to predict areas in a city where accidents are going to become more prevalent, and then take remediation actions. How about government vehicle route? In each one of these scenarios, Julie and I have had customers talk with us about, and they're at different evolutionary state in looking at these solutions. But you could have specific routes that are intended for fleet vehicles, and you're looking for anomalies. Well, if a number of fleet vehicles aren't following the defined route, maybe a route needs to be adjusted. And this is more kind of IoT location-based information. And another one, which is very topical for us now, is impervious cover identification. This is a big one, and I see heads nodding. Austin, they want to know where has impervious cover increased over the past year, and I want to go to those parcel owners and I'm going to charge them more because they stood up a carport or they stood up a pool or a shed. So they said that currently they do it manually, and it's on image data that's 2 years old. Forget about the the fee ramifications, the revenue ramifications. There's also a watershed ramification here. And they were looking manually at all the parcels and scoring them for how much impervious cover. So imagine an AI model that could give you back the percentage of impervious cover in a given image. And we're going to look at a solution in the custom AI side that does this. So when we look at that solution, we're going to be focusing on a Geo AI data science virtual machine in Azure. And this was a tight partnership with Esri a year or two ago. This virtual machine has pre-installed a number of data science Python libraries, Python and R development interfaces and environments, ArcGIS Python libraries. Did I say it as ArcGIS desktop deployed? It's really and then you can tune it and stand it up with GPU. So let's take a look at that. So you can go out to the Azure Marketplace and you can just grab this thing. And then as you click through it's just a clicking process. It's a few clicks. You can indicate what kind of GPU horsepower do you want this VM to have. And I set mine up with 6 virtual CPUs. I think I cranked it up to 36 to create my demo video last night. Click on Create. And then in the cloud, we chug away and we lay down all of the necessary services needed to support this VM. And then you can connect to that virtual machine using RDP, remote desktop. And now your team, your Python developers, your data scientists, they can go out to GitHub. Who knows what GitHub is? Excellent. They can go out to GitHub, and we have a few GitHub repos. One of them is the pixel land cover classification repo. And just march through the steps, and through marching through the steps, you're training a model that will recognize land cover. It'll recognize forest, grasses, water, and impervious cover. So you give the model an image, and it will give you back a 4-color coded layer on top of it, indicating what the model predicts. You could see how you could use that for something like Austin. So let's go ahead and take a look. If a video is made within 24 hours, it's considered a live optimized demo. So you're going to see a live optimized demo because I made this last night. So at the bottom, this is ArcGIS Pro Desktop, and you see a blank pane at the bottom. And in that pane, I am going to drag and drop NAPE imagery from the catalog portal. And then what I'm going to do is I'm going to create a custom raster layer on top of it. And you're going to see that before your very eyes in this live optimized demo. And that custom raster function is going to ask for an input, and I'm going to show that to you. And then we say, and I want you to use this train model, this model that you just trained using that GitHub repo. And in doing that, you're going to see real-time predictions. So we go to the portal, and we search on NAIP, and I grab the NAPE imagery, drag it onto that blank pane. And I don't know ArcGIS Pro Desktop stuff enough, but it zoomed way out. So I zoom back in. I'm going to zoom into the New England area because the model is trained on the geography in that New England area. So let's get to an interesting level of imagery. We have some structures, man-made structures. We have some water. We have shrubberies, trees. So that looks good. And now, and you can see where I have the mouse pointer, you can see I'm pointing to some of the impervious cover. You can see some of the roadways. Obviously, there are some ponds. And if you even just try to take your eye visually and look for all the areas of water, it's not super easy to do. But let's go to the raster function. We're going to build this layer. We click on custom. By virtue of following the steps in that GitHub, we laid down a custom function called classify. This is just in the steps, probably for your people in your team. Now we fill out an input parameter, and we say, I want to use that NAPE imagery as the image. So whatever's currently shown there, that's going to be the image. And now I need to indicate, well, where's the model that was trained that's going to take that image and then produce the predictions pixel by pixel. That's a lot of compute horsepower. Think about the number of pixels there. So I need to go out and grab that model that was trained. I know this is a little geeky. When you ask architects to come up and present, things are going to get a little geeky, probably a little quirky. So now I'm going to right-click this model. So I need to grab the location of it and put it in that input parameter. So we'll go ahead and grab that location. We'll copy. And go back to our raster function and paste, and then type in 250 epoch.model. The model was trained on 250 epochs, and that needs a lot of GPU horsepower to train that model. And we're going to choose hard max. That means for the layer, when it's displaying, I only want to display the color for the most likely predicted land cover type. So if it's impervious cover, it's going to be brown. If it's water, it's going to be bright blue. If we think it's forest, it's going to be dark green. And if it's going to be grasses, it's going to be light green. So we're only looking across those 4 measures. So that's pretty compelling. You can imagine how you might operationalize this for that Austin example. Just give me the percent pixels that are impervious cover a year ago, and then give them to me again currently. And then where I see there's a disparity, particularly an increase, then I can take appropriate actions. And as I zoom in, you're seeing real-time, pixel by pixel execution of that model that was built. Remember, this is custom AI. So now I'm going to turn off that particular layer. And I just want to show it to you really quick when you use the softmax. And we're going to go through the same steps to indicate what the input is. It's identical to what we just did, and give it the model. But we're going to leave the output type as softmax. And what that will do is it will create a shade, a gradient based on a weighting. So 60% likely to be impervious cover, 40% likely to be water. It's going to be a color that's mostly brown with a hint of green. Does that make sense? So then you can look at this layer when it's displayed, and you can see wherever it's kind of soft, that means that maybe the probability isn't spot on. Where it's a deeper color, it's much more likely. So that is custom AI at work, solving some very important business problems. So I'm going to transition now to pre-built AI, the other end of the continuum. And pre-built AI, we provide roughly 30 cognitive services, and these are all trained for you. No Python needed. So if you look under the language category, you're going to find text sentiment. Give us text, we'll give you sentiment. You're going to find text key phrase. Give us a text, and we're going to give you the key phrases. You'll find computer vision. Give us an image, and we have thousands of objects that we've been trained to recognize in the image, and then we'll put the likelihood that that image is in there. So state building, 80% likely that's in the image. Blue sky, 90% likely. And then we'll even provide a little narrative about what we think the image is about. That's computer vision, kind of a get what you get. There is another cognitive service called custom vision. And don't confuse the word custom there with custom AI, because custom vision is about an easy way to drag images into a portal, tag the images, and then train a model. So you're actually training your own custom model, but you're not writing any code. And then we host the model, and then you can call into the model. And with that, as promised, we're going to look at a pre-built custom vision solution. And I'm going to turn it over to Julian.
Thank you very much, Dave. And actually, Dave, I do want to correct you on that. We actually have 31.
We have 31 now?
Yeah, we actually just submitted one yesterday for a pepper identification. So we want to make sure that you're fine with that as well.
Yeah, I could have used that yesterday.
Yeah, you could use that. So thank you, Dave, and welcome everybody to our conference. And I want to actually showcase a solution based on this pre-built AI that Dave talked about. And it's really a joint product between Microsoft and Esri. And this solution is available to cities and counties. And the idea behind the solution is to allow you to fight blight. Fight, report, and obviously identify blight. And what blight is basically properties that have undesirable conditions, right? So one of the things that we want to identify in this particular environment is the ability to very quickly identify these properties given the nature of the photos itself. So let's look at the application real quick. And the ArcGIS-based application provides a portal for an inspector, for example, or even a citizen to be able to access this portal. And when they come across a property, they can upload the pictures of the property to the system with the geospatial coordinates. And if you look on the right-hand side of the screen here, it provides a function where the inspector or the citizen would go through a property condition survey and answer a few questions. And the property condition survey is really designed to manually tag the condition of the property. So you can see if we go through the process real quick. Is there a structure? Yes. Is there overgrowth? Yes. Is there roof damage? Doesn't look like it. Is there exterior damage? No. Is there graffiti? No. Are the windows or doors boarded up? Cannot really tell, so I'll click on maybe. And then the citizen or the inspector can then submit the survey. So as you can see, it's pretty straightforward. It's not really very difficult. But if you think about expanding this, especially to all citizens, the amount of photos that's going to be uploaded and the amount of manual tagging could be very big. I mean, that overhead is really huge. Not to mention that the human eye could only see to a certain level. So like, for example, the last question right there, whether it's boarded up or not, I cannot really tell. But there is value in in capturing this data. So, for example, the Missouri Department of Conservation took that data and they created a dashboard, right? And this dashboard provides them a visual display of the conditions of properties and blight in their geographic area. So the heat map here shows you the distribution of the properties. And in the bottom right-hand corner, you can see that the user of this dashboard can really drill down to the specific type of conditions they're most interested in and expose the parcels that are related to those conditions. So if I click on a parcel, I'll be able to further drill down on the heat map, expose a parcel, there's a blinking pixel right there. If I click on that parcel itself, it's then able to expose the photographs associated to that particular parcel. And you can see over here, this property might be overgrown. And that's the kind of information that this solution would be able to provide someone to basically expose and track and take remediative action for these properties. So we talked about how it is that it is very difficult to do a lot of manual processing. So let's take a look at how that partnership comes into play. So from a Microsoft perspective, we can bring a custom custom vision AI backend. So what you see here is the model that Dave just talked about. It's a custom vision model. And what I've done is that we are working with the City and County of San Francisco, and we've uploaded a number of photographs from the City and County of San Francisco. On the left-hand side there, you'll see that we have created tags that are also interesting to them, whether it's boarded up, whether it's graffiti, whether it's overgrown. We even have one tag that says non-blight, conditions of property that has no problems, because we really want to make the model as accurate as possible, and we want to know what a good, quote-unquote, property looks like. So, for example, it's a multi-tag model. This storefront on Market Street in San Francisco is both boarded up, and on those boards, there are also graffiti. So we put 2 tags on these photographs. But we also uploaded stock photos because we want the model to be a lot more accurate. So we uploaded this stock photo right here. It's not in the City and County of San Francisco, but we wanted to have a picture that really depicts something that's boarded up. So we tagged it as boarded up. And these photos, both stock and actual photos, are used to train the models that you see over here. And look at those numbers next to those tags. I mean, there's only 12 to boarded, 21 for graffiti. The idea is if you add more photos and tag them accordingly, the model is going to improve over time. So the portal also allows you to look at the performance of the model. As you can see, Dave and I actually went through 6 iterations of this particular project at a point in time that we kind of made this video. And in each iteration, the accuracy improves, and that's why we did things like adding, the stock photos, for example. So this is how we are able to tweak the model very easily, no special software needed. Now, to consume the model, if you look at the consumption model, it is purely a REST API endpoint. So any open application would be able to consume the REST API endpoint, pass it a prediction key, and that is how you would consume the model. And the model will then take the input and be able to provide the prediction based on the input. In this case, it is a photograph. So if you think about it, that manual process of tagging, remember that previous demo that we talked about from the Esri standpoint, that's where the partnership came in, right? We got rid of the manual tagging process and have that application call out to this model and then wait for a JSON tag to come back with the predictive analysis of that photograph. So just to simulate it, we're going to go ahead and look at that very same photograph we talked about earlier on, get rid of the condition survey, and then basically save the file to the computer. This is just purely for the demo purpose. Now I'm going to go ahead and use the interface to quickly test the model. So I'm going to select the photograph, and I'm going to upload it to the model itself. Now, don't blink. It's going to be very quick, but this is actually in real time. It shows you how quickly it is. So look at the spinning circle once we open the file and see how quickly it actually analyzes this photo. And there you go. What was it, like maybe sub 1 second? And you look at the right-hand side. That is the JSON tags that the model sent back from a prediction standpoint. So you can see it has a high level, over 75% of overgrowth, very small percentage of graffiti or boarded up. So, from a developer standpoint, I'm going to just assess the probability and say there's no graffiti, there's nothing that's boarded up, and it's definitely not a property that is in a non-blight situation, right? So that is how you would consume the model and also get the JSON tags and be able to respond according to the JSON tag and maybe reflect it in the heat map as well that we saw earlier on, and completely getting rid of the manual process. So let's go ahead and do one more, and we'll look at the actual city and county of San Francisco project. This is actually their ArcGIS system. And these are actual photos from their system. And I'm going to look at this one particular property, which is somewhat challenging. And so instead of saving this property, I'm going to take the URL of this property and just basically forward the URL. And this shows you that you don't actually have to download the picture. So if someone sends the picture through a reference of the picture through a URL, it can consume it, and it comes back with over 90%, almost 100% graffiti tag, and over 90% that is boarded up. And in the city and county of San Francisco, this allows them to route it accordingly to the right department. So just so you know, if you're a property owner and you do have graffiti, they send you warnings, and if you don't remediate their condition, they'll actually send city workers to kind of paint over the graffiti and send you a bill, right? The other interesting use case is that the police department actually used the graffiti information for crime speculation. So apparently graffiti, and I'm just learning this, do have signature properties that might identify gangs. So think about it, that heat map could now potentially be a heat map that actually looks at potential crime areas or things that might happen as it relates to crime. So SFPD actually shares the same information that the Department of Public Works, in this case, uses. There are other use cases as well that doesn't have to be related to properties, but just kind of get you guys thinking. We have the Washington State Department Labor and Industries. They trained a model to identify unsafe working conditions. So they've uploaded a whole bunch of photographs of power cords that are not taped down properly, right? So the idea is that if an inspector comes to a work site and take a photograph, they should be able to see power cords that may be a tripping hazard across the board. We have the Fish and Wildlife, where they're identifying invasive species. So there's a lot of use cases as it is with the custom vision. But coming back to this solution, this is our Better Together story. It is really our partnership with Esri to be able to bring together their expertise in geospatial data and getting rid of manual process with our cognitive services and be able to provide you with a solution that is very easy to consume. Thank you.
That was kind of a big finish. The call to action is, as CIOs and leaders in your industry and for your agencies, hopefully you've seen some ideas around how AI might enhance your business, and that's really what we hope you took away from this, is a little inspiration around what you can do with AI. Here are some search phrases you can look at to see get more information about what we showed you, and thank you very much, everybody.
Thank you. Thank you.